Alright, so we're going to do a quick presentation to review what we looked at last time we were together in the Desmos app. And this was one of the last slides of part 1. And if you remember part 1, we were just looking at the way a graph is shifted up, down, and also side to side. Now, if we're given an equation like this challenge equation where we have something written inside the parentheses here and something written at the end, we can then move to all these different graphs and pretty quickly be able to tell which color matches this equation, right? So the way I can do it, first of all, is by focusing on the vertex. And I'm going to pull up some of the points here that are our vertices. And the vertice in our quadratics is what we would refer to it's an important point. It's either the lowest point in all of these examples, it's the lowest point, or if our parabola is opening downward, it'll be our highest point. But for these, it's our lowest point. As we can see, we have a -4, x minus 4 inside the parenthesis, and that actually moves the graph to the right 4 units. And then we have a -3 at the end, and that moves our graph down. Some of you might think about that as the starting point. The starting point is shifted down 3 units. So if we look at that new vertex using those two numbers in the equation, right 4, down 3, we can identify it has to be this pink function, and we would then move on from this question, right? Okay, so we are looking again at an equation that looks similar. We have parentheses around this x, we have a value subtracted, and we have a k value at the end. And these are just variables that we use in our language of mathematics commonly to stand in place of the horizontal shift. That would be h, and the vertical shift, that would be k, right? So if I look at k first, I can change my slider, so that's going to be this value at the end. As I move this slider down, my graph shifts down. As I move it over in the positive direction, it shifts up, okay? Now, if I were to go to my h and change my h, as I increase the value of h, my h is moving over. As it decreases, it's moving in the other direction. -h plus h. Now, one of the interesting things that happens because this equation is x minus h is that when h is a -5, that actually simplifies to x plus h. So we have to keep that in mind when h is negative. When we write it inside the equation, the value of the negative sign flips because we have a minus, a negative. So common mistake that can be made, and I'll just ask you to be very careful when you're doing these types of problems. So again, k is our vertical shift, h is our horizontal shift. Okay, the next shift that we looked at, or transformation we looked at, was what would happen if we placed a number in front of the x squared. So in this case, we have a number 4. It's a number greater than 1. And so what happens is we can see the blue graph, this is our 4x squared equation, is actually steeper than our original equation, right? It's getting skinnier, it's getting closer to the y-axis, and it's that vertical stretch is happening with the graph. It's getting vertically stretched. And alternatively here, the value we've put in front of x squared is something less than 1 and greater than 0. So it might be a fraction or a decimal. And what happens is that instead of getting stretched vertically, it's getting compressed, which means it's opening up, it's getting wider, it's getting flatter, right? All of these different ways that you can think about what's happening to this equation. It's getting closer to this x-axis here. And then one of the last transformations, one that a lot of people were already familiar with, is what would happen if this a value was a negative, right? So how would that transform this graph? And what we found was that it really just flips it over the x-axis. So instead of opening upwards, it's opening down, right? Instead of looking like a valley, it looks more like a mountain.